Hello everybody, welcome to another session of DS for HS. Today we're going to talk about the Berkeley Datascience bridge between Numpy and Pandas. Now, today we're going to talk about and examine how the Berkeley Datascience library acts as a powerful educational bridge or connect between the two leading data science libraries, and those two are Numpy and Pandas. And I know we've talked about those two, but the Berkeley Data Science library really bridges them all together. And let's look at how through our hands-on practice. So let's start by importing the Berkeley Data Science table module and reading in a sample CSV. So we're doing from Data Science import table, because we only want to import the table module of Berkeley Data Science. And then we're doing table.readTable, so we're reading in this CSV file, and we're assigning it to the variable t. Now we're going to call t here, boom. As you see, it's a table of rows and columns. However, under the hood, Berkeley tables are sequences of NumPy columns. And what we mean by that is here you see a table, but each column is a NumPy array. So each column is a NumPy array. And we'll see what we mean later on. Now, we're going to prove this with our hands-on learning that Berkeley Data Science tables are sequences of NumPy columns, or NumPy arrays. Now, let's make this statement. Berkeley Data Science tables are sequence of NumPy columns come to life with hands-on learning. So I'm going to comment this out first. So this Berkeley Data Science table method, t.columns, returns a tuple of NumPy arrays, contain all of our data in our contain all of our data in our table. Notice the absence of the column heading names. We can walk through the sequence of columns using standard Python square bracket syntax. So here, this is a tuple. We know it's a tuple by the parentheses. So that just shows us it's a tuple, and here it gives us all the arrays, but it does not give us the heading names. So here, instead of saying date, it just gives us the dates. Instead of saying transaction, it just gives us the transaction. It doesn't show us the headings. Now here we're doing t.column, so same thing, square bracket 0, so it's going to give us the very first element, boom, and that's what it does, and it gives us the very first array or first column. Now we're going to see what type this is, and as you can see right here, it's an array, a NumPy array. And then we're going to do the same thing for the second column. It's square bracket 1 because remember we index at 0, so we start counting 0, 1, 2, 3. Instead of counting 1, 2, 3, we count 0, 1, 2, 3. So here's going to give us the second array, the second values in the columns, and that's our transaction. And then type is going to be same thing, NumPy array. And our third is the category of where the transactions occurred. And we're going to type, and it's going to be the exact same thing, a NumPy array. So what we created was just a tuple with all these NumPy arrays. Now we're going to do the exact same thing, but with a dictionary. So we can provide more hands-on proof that Berkeley Data Science tables are a sequence of columns composed of NumPy arrays with the following dict.t. And what this is going to do is this is using the dict built-in function, the built-in Python function. We know it's a function because it's light green, and we're converting this table into a dictionary. Now here's really cool because a dictionary, as I said in earlier videos, is you can tell by the curly brackets and also the key value pairs. So we use the column names as the key, and then the values is the NumPy arrays. So it's very, very cool. Now here, we're going to do dict.t, so we get this dictionary again, and then do date. And then when it does that, when we type in date in square brackets, it's saying, give us everything, give us all the values that are related to the key date. So we only can do this with keys. So we don't have to do an index number, we just typed in the name of the key. And then here we're doing type of dictionary, and then where it's correlated to the key date. And then we're going to get exactly what you think. It's a NumPy array. Exactly. Because we see the value associated with the dictionary key date is a NumPy array. Now we're going to do the same thing. Find the values that are associated with the dictionary key transaction. Boom. See the type. And it is a NumPy array. We're going to do the same thing. See all the values associated with the key description. See the type. Boom. And it gives us the description of the restaurants that the purchases or the transactions occurred at, type, and you guessed it, NumPy array. Now, finally, let me comment this out real quick. Finally, applying standard Python bracket syntax to a Berkeley Data Science table extracts specific NumPy arrays from the table. So that's what we're going to do. So this is, forget about the dictionaries, forget about the tuples, this is just our standard table. boom, and it pulled out the very first column, which was the date. It is truly beautiful how clean the interface is between Berkeley Data Science and Numpy arrays. Here's going to give us the second column, boom, and that is transactions. This shows us that we can separate a Numpy array from a Berkeley Data Science table with ease, with very much ease. So it's very easy. And then we do the same thing here for the third column, and boom, it gives us the description. So that's what it is. Just Berkeley Data Science tables are just a collection of Numpy arrays. So each column is its own Numpy array. Now, let's convert Berkeley Data Science tables into Pandas data frames. Let me comment all this out before we get into it. Okay, so first we have T, which is just our regular Berkeley Data Science table. So bada bing, bada boom. And as I said earlier, each column is its own Numpy array. So this is a Numpy array, 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 and Berkeley Data Science just ties them all together. So it's the glue that holds those arrays together. Now, let's check its Python data type. We see if it is a data science.tables or quite simply a Berkeley Data Science table. So let's do type T, and it is data science.tables.table or a Berkeley Data Science table. Now, we're going to apply the to_df method to our Berkeley table, and it is converted into a Pandas data frame. So that's what we're doing. So we're doing T, the name of our Berkeley Data Science table, and then applying the method to_df, which means data frame. In Pandas, when you have a table, it's called a data frame. So what this does, it's converting it into a Pandas data frame, and we're assigning it to the variable df. Now we're going to call df, boom, and it looks the exact same, but there's some subtle differences. It shows us the index number. Starts at 0 because you guys remember we indexed at 0, and we can also prove it's a Pandas data frame by doing type. Sorry, I did a capital T. Type, boom, pandas core frame dot data frame. So it's a Pandas data frame. Now, check the GitHub repository to actually see the Berkeley Data Science table source code for to_df or any other table method. So if we go over here, we can see the actual method, and this is the source code of the method, and it tells it what it does. It says convert the table to a Pandas data frame, and we use to_df, and it says return to the Pandas data frame of the table. It just converts the table to Pandas data frame to see what we can use data frame instead of the table at some required places. Here's an example of using to_df method. So table with columns, blah blah blah. You assign it to the name table. And then here's what it's going to look like. That's a standard Berkeley Data Science table. And then, sorry about that. It's up here, and then we do table.df, and then we assign it to table_df type. It shows us Pandas data frame and Berkeley Data Science table. So it just shows us that this is the source code and what this method does. And on this GitHub repository, you can see the source code for a bunch of other functions and methods. Now, once your Berkeley Data Science table is converted into a Pandas data frame, you have access to the extensive library of Pandas methods. Pandas has such a vast and wide array of methods, and this library is a testament of that. So that's what we're going to do. We're going to do dir to see the extensive library of Pandas methods, and then we're going to print it out so we get a nice list. And as you can see, there are over 100 Pandas data frame methods. So these are all the methods. It just shows us that Pandas has a lot of them, but not too many. Not too many. At any time using the Berkeley from_df method to convert a Pandas data frame. At any time use the Berkeley what this comment is trying to say is you can use the from_df method to convert a Pandas data frame into a Berkeley Data Science table. So it works two ways. It doesn't just convert tables into data frames, it can also convert data frames into tables. Now, this notebook was a lot of fun. We examined how the Berkeley Data Science Library acts as a powerful educational bridge between two of the leading data science libraries, Numpy and Pandas. In our next video, we're going to explore the special data science features and benefits of both Numpy and Pandas. So guys, Numpy and Pandas, stick with it. I know it might seem hard. You can go back to former videos, but these two libraries are super duper important. especially for a data scientist, but in any computer science related field. So you're going to need to know these libraries, but once you've conquered them and mastered them, you're going to be so glad that you did. And here we have an appendix, and this just shows us all the commands that we used on the operating system level. Don't worry too much about this. We'll get to that in more detail later on. Guys, remember, practice, practice, practice. Your remote desktop is always on 24/7, 7 days a week, 24 hours a day. Use it in order to get good at this stuff. These notebooks are always available to you. These videos are always available to you. The resources are there for you at your disposal. So take advantage of them to the max. Thank you so much. Have a good one.